Good morning. Hope everybody's doing well today. Welcome to RMS618. This is actually Module 4 discussion on multivariate analysis of variance, MANOVA. Now there's going to be a little bit of discussion on multivariate analysis of covariance and some other stuff with repeated measures, ANOVA and stuff, but most of the discussion today for this Module 4 segment will be on MANOVA. Let's just review ANOVA a little bit. Yes, it is similar to the two independent sample t-test, and we said in basic statistics that ANOVA is an extension of the two independent sample t, looking for significant mean difference between 3 or more independent groups. Some might say 2 or more, but typically it's 3 or more independent groups. In the one-way ANOVA that we studied in basic stat, we have one dependent variable that is continuous and one or more independent variables. Now in the one-way ANOVA we have one IV, we call it a factor. And in the two-way ANOVA, which is the factorial ANOVA, we have two factors. Could be IVs, you know, usually one is an IV, whatever. But these IVs, regardless, are categorical. There are many different types of ANOVA. There's a whole family of these ANOVAs, and in basic statistics we studied probably the simplest one, the one-way ANOVA, where we have one factor. If it's an experiment, it would be indeed an independent variable. With 2 or more levels. It's usually 3 or more levels. If we had 2 levels, we would run a 2 independent sample t-test. Okay, so typically 3 or more levels. The two-way ANOVA is also called the factorial ANOVA, in which case we have 2 factors. Now if this is an experiment, we might have 2 IVs. With actually 2 or more levels, typically 2 or more or 3 or more or whatever. So the two-way ANOVA is the factorial ANOVA. One-way ANOVA is the one-way ANOVA. The MANOVA is actually called the multivariate analysis of variance. The multivariate analysis of variance. And this is actually an extension of the one-way ANOVA that tests for the effects of one or actually more independent variables on 2 or more dependent variables. Now a typical multivariate analysis of variance has one factor, just like the one-way ANOVA, with 2 or more dependent variables. Okay? Now these independent variables are categorical. The dependent variables are continuous. And again, we have assumptions. We have that independence assumption, just like we had in the 2 independent sample t-test and the one-way ANOVA. Okay, our groups are all independent of each other. Okay, our groups are all independent of each other. It assumes equal group sizes, but that doesn't necessarily have to be the case. We have our good old homoscedasticity assumption, homogeneity of variances. We have a couple other tests we actually have a couple of tests for homoscedasticity in the MANOVA, boxes M and Levine's test, which we will see down the road a little bit. We have some terminology, some new terminology. I use that term factors. So a factor, in the experimental sense, are the independent variables. So if we're administering some treatment, we know that it's an experiment and it's indeed an IV, and we call that a factor. And we have levels of these factors. So for instance, if factor A was college, we might have 4 levels of that. Okay, a group of freshmen, a group of sophomores, a group of juniors, and a group of seniors. The main effect is the direct effect of an IV on the DV. So in studying the one-way ANOVA, we remember that if that omnibus F was significant, we can conclude that we have a significant effect. a significant overall effect. In MANOVA terms, this is called a main effect. Okay, and if we remember, when we took a look at the two-way ANOVA, the factorial ANOVA, we had the A main effect, B main effect. Okay, so this term, it should be familiar to you, and the interaction effect. And we know that as the joint effect of two or more IVs on the DV. So we have these main effects and these interaction effects. Good old SPSS screen again. This time for MANOVA, we have our variables. This is type of school. This is the Raven variable. Reading and composition. Let's see where this is going to take us, what kind of research question we're going to have to answer. We have two dependent variables, reading comprehension and composition, and a fixed factor, which is the factor A, school, and it's most likely type of school. We're wondering what the effects of the different types of school are on two DVs, reading comprehension and composition. Let's advance the screen here. So our factor is school. Okay, it's going to display some descriptive stats, some estimates of effect size, some homogeneity of variance tests. We have some more screens. It's going to run post hoc tests. We, in this case, chose Bonferroni. Now, in basic stat, if you remember, we talked about that there are a number of different post hoc tests for significant omnibus Fs. Tukey, here's the Tukey, see? There's the Scheffé. There's also one called Dunne, and Bonferroni is really popular. So they're all pretty much the same. We're going to, in this case, choose Bonferroni. We're getting some output now. This is homogeneity of variance output. We see a non-significant p-value here. What does that imply? We accepted the null. What does the null imply? Equality. In this case, what? Equality of variances. So this non-significant p meets the assumption of equality of covariance matrices. Okay, this is a nice little way of doing this. So whenever we have a non-significant p-value, the null is true. We have equality. Remember, the null implies equality. Okay. Now we're getting into some results. Are the combined DVs significantly different across 4 schools? Now, if you remember in your study, it wants us to focus on, there are different types of the omnibus F statistics in MANOVA, and it really wants us to focus on Wilks's lambda, but there are others as well. Okay. But as we see, we have significance. We have overall omnibus MANOVA F significance. And look at the notation. At 6 and 538 degrees of freedom, F is 9.029. P is very, very small. It's less than an alpha of 0.1, and we rejected the null. What does this mean, class? It means that we have overall significance. In a real general sense, we have overall significance across all the schools on the dependent variables. Fairly small effect size, though. Fairly small effect size, 0.091, which we see right here. So this F of 9.029 is right here, and so on and so forth. So this is typical MANOVA SPSS output. So are the combined DVs significantly different across 4 schools? Yeah, apparently so. And we would base that on these very, very, very low p-values. Okay. Another test for homogeneity of variance. What do we see here? Well, in both cases, we see P greater than 0.5 for our IVs. What would we conclude? That the variances are equal. Okay, so in both cases, the null was accepted. What does the null imply? Equality. So if P is greater than alpha, both error variances for these particular DVs are indeed equal across groups. Test of between subjects effects. Now in your MANOVA course material, in your module, it told you that if we have a significant omnibus MANOVA F, we have a series of post hoc tests. The first one is a series of univariate F tests. It's a series of one-way ANOVAs on each dependent variable. A series of one-way ANOVAs on each dependent variable. Okay? Well, in this case, the ANOVAs were significant. Okay? We have a very small p-value here and a very small p-value here. So the one-way ANOVA on reading comprehension was significant. The one-way ANOVA on composition was also significant with, again, fairly low effect sizes. So let's see what we have. The main effect of school on reading was significant. Yeah, see that? F at 3 and 270 degrees of freedom was 4.659. Okay, here we are. P is 0.003. It's less than alpha. We reject the null. And the main effect of school on composition was significant. F at 3 and 270 degrees of freedom is 14.253. Here we go. And we see P is very, very small, less than alpha, and we have a fairly small effect size. Okay, so we have, significant post hoc one-way ANOVAs on each of these DVs. Now let's proceed. Now we go even further. We get more specific with these Bonferroni post hocs. Now look at this screen. There's a lot of numbers here. Don't let this intimidate you. We have D1, dependent variable 1, dependent variable 2. Now look at what they're doing. On reading comprehension, we had 4 different types of schools. Okay? School 1 versus school 2. Look, non-significant. School 1 versus school 3. Significant. School 1 versus school 4. Non-significant. And there's some repetition in here. Because now we have school 2 versus school 1. Look, non-significant. 2 versus 3, non-significant. 2 versus 4, non-significant. And again, 3 versus 1, significant. Well, that's the same thing as we had here. And so on and so forth. Okay, so this is getting very specific as to where the significant differences are on the respective dependent variables with regard to each of the 4 levels of factor. School number 1, 2, 3, and 4, whatever they may be. So again, we see significance and non-significance. Look at in the composition, 2 and 1 are significant at alpha 0.5, 2 and 3 are significant, 2 and 4 are significant, and so on and so forth. This is getting way more specific now as to where the significant differences are. So this step-down analysis goes from, if we have a significant omnibus MANOVA F, we do a series of one-way ANOVAs on each dependent variable, which we did in the last screen. If any of those ANOVAs are significant, we proceed further. We proceed further to how we would treat any generic one-way ANOVA with post hocs. Could be a Bonferroni, or you could choose a Tukey or a Chaffee or whatever. But all we're doing is just getting way more specific as to where the significant differences are. Okay. Reporting results. Boxes M, boxes tests indicate that the assumption of equality of covariance matrices was met. Why? Because P was greater than alpha we have equality. Okay? Levine's test showed that the assumption of equality of error variances was met. Because p was greater than alpha, again, we have equality. The combined dependent variables were different across the 4 schools. So that omnibus MANOVA F was significant at actually alpha 01. The main effective school on reading was significant. The effect size was 0.049. The main effective school on composition was significant. Okay? The effect size was 0.137. Bonferroni multiple comparison indicate that there is significant difference in reading comprehension between school 1 and school 3 and many more. Okay, so you just have to kind of go through, earmark all the significant p's. All p-values that are less than 0.05, that's going to tell us specifically where the significant differences are. Multivariate analysis of covariance. So this should be multivariate analysis of covariance is identical to the MANOVA with one thing. We identify a covariate, we factor out the effects of the covariate, some potential confounding variable. It gives us a clearer picture as to what's going on. So, yes, it's an extension of ANCOVA, okay, and ANCOVA is actually an extension of the one-way ANOVA, okay. So all we're doing is identifying some potential confounding variable, and then factoring out the effects of that potential, confounding variable. Gives us a clear picture as to what's going on in terms of F. So yeah, it's the same as MANOVA, except for the covariates. So, other variables, potential confounding variables. And we call these control variables. We're factoring out the effects of these continuous control variables. Here we go. A MANOVA, but in the MANCOVA sense. We have our 2 DVs, reading comprehension and composition, with our fixed factor school. So we have one factor A with 4 levels, right? School 1, 2, 3, and 4. We're going to identify the covariate. This is the potential confound. So we're going to factor out the effects of this particular variable Raven on the DVs, and it's going to give us a clear picture as to what's going on. Let's see how we progress here. I do not want this slide. This is not correct. Heidi goes into some, she just kind of gets off a little bit and goes into some other things. So she talks about repeated measures, okay? Kind of gets off the subject of what we're doing here. Repeated measures is an extension of the correlated t-test, where we're just looking at one single group of participants measured more than twice. We remember in the correlated t, that paired t-test, we had the pre-test and the post-test. This just extends that. So whereby the one-way ANOVA is an extension of the 2 independent sample t-test, the repeated measures ANOVA is an extension of the correlated t-test, or the paired t-test. It's also called the dependent sample t-test. Okay. She's talking about repeated measures. It again, analyzes the DVs measured at multiple times using repeated measures analysis of variance. We have one single group of participants. The IVs could be categorical factors or continuous covariates. Now we're back to MANOVA. We're back on track here. Perform MANOVA on manova.save to determine if there is a difference between the modes of how information is presented among the 3 groups. So we have one factor A with 3 levels. The researcher is examining the effect on usefulness, difficulty, and importance. Looks like we have 3 dependent variables. Now again, we do the drill. Does this meet the assumption of homoscedasticity? So we're going to talk about boxes M and Levine's test. It's actually called Levine's test of sphericity. Are the combined DVs significantly different across the three groups? We're going to see that. What's the effect of the IV on each DV? And that's the measure eta squared, also called effect size. Does this meet the assumption of equality of covariance matrices? Well, let's see. P is greater than alpha. I would say yes. So boxes M, in this case, is non-significant. So the null is accepted. What does the null imply? Equality. Okay? Equality, in this case, of covariance matrices. Equality of variance. That's actually one of the assumptions. Okay. Here's Levine's test. Okay? On the three DVs, we have the assumption satisfied here and here, but not here on the usefulness variable. It is what it is. So our results may be a little bit less than accurate. Okay, we didn't satisfy it at all three DVs, but again, you know, it is what it is. We have our output. Are the combined DVs significantly different across the three groups? Well, let's take a look. We have our 4 F statistics. The answer to the question is yes. Look at these sig values. All these p values are less than 0.5. So the answer is yes. Are the combined DVs significantly different across the three groups? Yes. What does this mean? It means that we have a significant omnibus MANOVA F. In a real general sense, across the three groups, we have overall significant difference, you know, across all the DVs. So in a real, you know, we have a significant omnibus MANOVA F. It's actually represented, you know, 4 times here. This particular class wants us to focus on Wilks's lambda, you know, again, which is significant. Now we're getting a little bit more specific, okay? The test of between subjects effects. This is the one-way ANOVA post hoc tests, all right? In this case, we have to do 3 of them for each DV. See that? We do 3 of them. And it's interesting to note that none of these post hoc one-ways are significant. None of these post hoc one-ways are significant. Could be a result of the violation of the homoscedasticity assumption on that one DV. Okay? So we have non-significant one-way ANOVA post hocs. So in this case, we would stop. I mean, the analysis is pretty much over. It's just the way the data comes out. Let's summarize. We talked about multivariate analysis of variance, looking for significant difference across, 2 or more independent groups on 2 or more dependent variables. And then the MANCOVA, which is just very, it's identical to this, except we factor out the effects of some third variable, some covariate, some potential confounding variable. This particular presentation talked a little bit about repeated measures, just the extension of the correlated T, paired T, or dependent sample T, between subjects versus within subjects, variation between groups, variation within groups, and the assumptions for MANOVA. Questions? Again, please write your questions down. Watch this video again. Ask me questions on the discussion board if you're a little bit confused, or email me your questions. That concludes this presentation on Module 4, MANOVA, MANCOVA. Have a great day.